Hello everyone. So today I'm going to show you about AI content moderation system we built. This is really amazing thing. So watch this video till the end and I will give you in-depth review of what we have built and in-depth analysis of code. So let's get started with why, right? Every minute, millions of pieces of user-generated content flood social systems and social platforms. The challenge: how do you moderate this content at scale while maintaining accuracy and reducing human workload? Today, we will build a production-ready AI content moderation system using event-driven architecture with Motia, as you know. And I will show you why this approach is revolutionary for modern applications. Traditional content moderation systems face three critical problems. Scalability bottlenecks. This occurs when monolithic systems can't handle traffic spikes. Coupling issues. One failing component brings down the entire system. Then hard to modify business logic or add new moderation steps. That is because of inflexibility of workflows. Most companies build this as monolithic APIs where everything happens in a single request-response cycle. This creates tight coupling between AI analysis, decision logic, and human review process. So as you can see here, this is a traditional monolithic approach where how analysis occurs. There is a blocking, and then when decision is done, it coupled, and then we have the notification for moderators, which is synchronous, and the execution is all or nothing. So at the execution, it is all or nothing. So this approach breaks down under load and lacks the flexibility modern application needs. Event-driven architecture solves these problems by decomposing the system into independent, loosely coupled components that communicate through events. Let me show you why this works. Asynchronous processing. Instead of blocking the user while AI analysis happens, we immediately return a response and process content asynchronously in Motia. So how it happens, I will show you in some minutes. This improves user experience and system throughput. Then independent scaling, because each component scales independently. If AI analysis becomes a bottleneck, we scale just that service. If Slack notification spike, we scale the notification service. Fault isolation. If the Slack service goes down in any manner, we have the event-driven architecture. So content analysis continues and the system gracefully degrades instead of falling completely. Workflow flexibility. Adding new moderation steps, changing business logic, or integrating new services becomes trivial. Just adding a new event handlers enough, right? That's what we can see in the event flow diagram here, which I have created. So content submission is done by content submit API, which triggers the event content.submitted. And then there is the AI analysis. I'm using analyzer where we use OpenAI for this. And then once it is analyzed, it is passed to the content router. Then if it needs a review, it will ask in Slack notifier. We have set some parameters, some thresholds for that, confidence score and all. So if it requires review, then it will send to notifier. Otherwise, it will automatically reject it. Yes, then if content reviewed, then from the Slack webhook, it is again passed to the action executor to execute. If accepted, rejected, everything, and you will see that details from the Slack in your Motia workbench directly. Very simple, right? So each arrow represents an asynchronous event, creating a resilient, scalable system. That's what we saw. Traditional event-driven system require complex infrastructure setup, message queues, event buses, service discovery, monitoring. Motia abstracts all this complexity while providing powerful developer experience. Look at this. This is our entire content moderation workflow. Visualized as a graph, visualized as our entire flow. Very beautiful, I would say. Like each node is step, each connection is an event. This actually show this in a couple of minutes for you. But yeah, let's first dive into the code, like how the code looks like. So on the screen, you can see there is a TypeScript types being generated, right? So these are automatically generated types. Motia automatically generates TypeScript interfaces for all events, ensuring type safety across service boundaries. This prevents runtime errors and makes refactoring very safe. Then we also have the built-in state management. So if we go to Slack notifier, here you will see we have the built-in state management. Here you can see how the Motia provides a distributed state management out of the box. No need to set up Redis or database for workflow state. Everything is inside is. So every event, every state change, every error is automatically tracked. You get observability for free. That's what we have seen here. So let's dive into our implementation. Our system consists of 6 major steps, each handling a specific responsibility: content submit, then content analyzer, content router, Slack notifier, Slack webhook, then action executor. And this features file is nothing but a tutorial which you must have already seen in our blog, which will be linked to this video, as well as it will be also available on blog.motia.dev. So definitely check it out. So let's jump into content submit API. Here you will see your content is getting submitted. So event emission is being done. So that's how you define the API in Motia. Very simple, I would say, like very simple to configure. And that's how it emitted the content submitted here. And as it is emitted, here you will see in await emit, we have immediately emitted this event, and then similarly returned immediately to user. So this is where you should notice like how we immediately return to the user after emitting an event. The user doesn't wait for AI analysis. That happens asynchronously, right? How the AI content analysis work. Here again you will see the subscribes and emits is there, right? It defines like how it listens to the submissions which we saw in the content submit API, and then emission is being happening for the results. Whatever analysis is generated, results are generated that are emitted again from here. So very simple kind of architecture and very simple to write. Means if you start using Motia, you will understand it is very simple to run and everything. So we have also implemented how to analyze the text, how to analyze the text analysis is done. Then we have written the prompt for image content, as well as image analysis is being done, and then overall scoring is done based on how the 0.85% for the rejection, and similarly for review and approval we have overall score, right? So that's how we have defined it, and you can easily change it, and whatever emit analysis we did at the start, right? So that results is being emitted directly for the next step. So key points to notice here is like you will see the parallel processing is happening all over across in one step. We analyze text and images simultaneously is happening. Then we also saw OpenAI integration is there for the, it is using both moderation API for text and ChatGPT for vision for image. Then we also saw the state persistence for storing submission data for downstream. Then we are also doing the event emission. So results flow to the next step asynchronously. Yeah, and one thing to notice here is like we are also doing the image safety analysis using GPT-4. So we are leveraging OpenAI's specialized models for accurate content analysis, which works like very easily. Moving to another step is content routing. So here intelligent content routing is happening, and one thing I would like to show you is handler here. Entire brain, I would say, of our entire project. So this is where the actual magic is happening. Intelligent routing based on confidence score. So here const are defined, right? And here we have defined that we have the emitted data and everything. So here you will see the overall everything is happening. So if high confidence clean content is there, less than 5%, equal to 5%, then it automatically approves that. And similarly for high confidence toxic content is there, which is like greater than or equal to 95%, it will just reject it. And in uncertain content, which is like 5 to 95, it will pass on to Slack for notification for the human review. And then once it is approved, rejected, then it will again go to the execution state, right? So this actually reduces all of the human workload while maintaining the accuracy. So that's why this is like perfect example of human in the loop We can move to the next step, which we talked about, is like Slack notification. So Slack integration for human review. Similarly, here also I will talk more about the handler. So submission ID, auto decision, overall score, everything points are done. Then notice that sophisticated channel routing is being done here, which you will see here, right? So notice like high risk content, which is greater than 70% or something, we are escalating it to escalate channel. And then if it is low risk content or something, then if it's like less than 50% and all, so we are just passing it to normal moderation channel. This ensures critical content gets immediate attention, while routing reviews don't overwhelm senior moderators. We have also defined the interactive webhook handling in the Slack. If you go to the interactivity and shortcuts, you can define the URL. So I have exposed my localhost 3000 where Motia workbench is running to ngrok, and then passing it here. So what is actually the interactive thing, right? So this is for the buttons on the Slack. So this webhook handles Slack button interactions securely. So let's say signature verification, then state updates, event emission, immediate feedback, everything happens here. So it prevents unauthorized requests, tracks who made a request, what decision was made, and also triggers a final action execution step, and also updates the Slack message. So everything is happening inside this one file. So this is the final step, and very easy step. Like it executes the actual business logic, publishing content, blocking it, or escalating for further review. Everything is happening here. It subscribes to the content.reviewed, and then of course it is not emitting anything. And then so it updates the Slack gets the Slack message, and then also check for the automatic approval, rejection, and everything is happening in a file. And yeah, that's how simple it is. Each step is independent, stateless, and can scale independently. State flows through the system via Motia's built-in state management. State is automatically persisted, versioned, and accessible across all steps. This event-driven approach delivers massive scalability benefits. Event-driven approach is like you can have like 10,000 requests per second, immediate response very easily. So we are utilizing everything. So if you properly make your infra, then it is very simple to do different things. So yeah, very easy. Let me show you quickly how this entire workflow looks like. We will dive into the demo. So first I will try it as a text, and then we can try it as a text as well as image as an input. So we just have to go to this content submit in API and then submit our payload. So when I play it, you will see very beautiful workbenches running here, and it says Slack notification has been sent. As you can see in the content moderation, it says like priority is very high, and it's like OpenAI analysis is being done, and it scores it as 80% risky. So it is asking me to approve or reject. So I will definitely go and reject it. You will see it is rejected, and then again Slack will automatically ran. You can also see in the logs like blocking content is been done and done by the user 456. So yeah, very simple and well done. So by my name, which is my Slack handle on my profile, right? So let's try it with the image as well as text. So I have another payload where I will try it with text as well as image. So let's go ahead. Content submission API, then Slack notifier. So looks like it automatically decision made for the rejected. So I will not get any notification in any of my channels. So because auto decision made rejected, text is harassment. So that's what we can see here in content moderation, escalated, urgent. We don't see any kind of a request being sent for the Slack. When we can actually see these stats as well as in our Motia workbench. So in the moderation, what is completed, what was submitted, what kind of images and text and everything. So this example is also available on our Motia examples repo. So if you are going there and you lost my video, or like you lost the blog or something, so definitely just click on this tutorial. You will see entire AI content moderation tutorial is been created. So that's what actually the features and tutorial for in our Motia examples repo. In this AI content moderation example, you will see there is a tutorials file. So this is created for you for the better developer experience. So you can just get started with this tutorial and you can actually run it by yourself. You can understand where was the step configured, where I can configure the where I can define the API endpoint, how the request body schema can look like, how event can be emission, request handler, everything is available here. And as you move to the last steps, it is like around 105 kind of steps. So definitely try it out. Very simple, I would say. Let me compare our Motia based solution with other alternatives you can look for this content moderation system, right? First of all, let's say you compare it with AWS Step Functions. So with compared to AWS Step Function, this has like better developer experience for sure. You will see like visual workflow, design, type safety, local development, everything is there. And it is very cost effective and open source, easy to modify workflows, add a custom logic. Similarly with Apache Kafka plus microservices kind of a setup, if you create, no Kafka cluster management, Zoogamer schema registry, then very faster development, built-in state management, monitoring, error handling. So type safety is there. Similarly, if you compare to temporal or cadence, Motia is an event-driven architecture, so natural fit for reactive systems, easy HTTP first, easy integration with existing APIs, visual debugging, so see workflow execution in real time, everything is real time here. So if I close here, you will see everything is real time here. You can actually view the steps, you can actually go to the traces, check the traces, you can go to logs, go into logs or states, and you can actually edit them. So very easily everything is available here. And custom event system, so built-in reliability, monitoring, scaling, and developer productivity is focused. So focus on the business logic, not infrastructure. No custom event bus to maintain, everything is inside. So hope you like this demo, and if you think like we should come up with more this kind of demos, then definitely comment in the video description. Thank you.